In this video, we are going to finish up our discussion of translating things vertically and horizontally by looking at the key features of graphs that have been translated in both of those ways. All right, so let's look at this one. I can tell this is going to be a parabola because I have a squared right here. That means it's a quadratic graph, and quadratic graphs make parabolas. Normally, my parabola sits right here with the vertex on the origin. But look at what I'm going to do here. This plus 1 is inside the function, so that's going to be a horizontal shift to the left. The plus 2 is on the outside of the function, so that's going to be a vertical shift up. So what that means is I'm going to take my vertex that normally is on the origin, and I'm going to shift it one place left and 2 places up. So there's my new vertex right there. And then I'm just going to attach my parabola onto that vertex. Everything in this section is just going to be a sketch. So I'm going to attach right there. All right, and that should really be right up there actually on the y value of 2. It's a little bit difficult to aim on my screen with my finger. All right, so domain. Remember, domain means all the possible x values. So look, how far does this one go to the left? And how far does this one go to the right? Well, those arrows are telling me it's going on and on forever to the left and also on and on forever to the right. So the domain of that is going to be all real numbers. Okay, so how about range? Range is all the possible y values. We look at range from bottom to top. So the lowest that this graph goes is right there at the vertex. And for range, I want the y value of the vertex. Well, how high did I move up? That's right here. I moved up 2 units. So my range is going to be 2 to positive infinity. And I can see that it's going to be a bracket on 2 because it does actually reach 2 right here. Okay, x-intercept. So how do I go about finding the x-intercept? Well, if you remember, to find the x-intercept, I would substitute in 0 for y and solve for x. But this time I can see in my graph that I don't actually ever cross the x-axis. So I'm just going to write none. If I tried to solve that, I would get something imaginary, which cannot be put onto my real axes. Okay, so how about y-intercept? Well, the y-intercept, to find that, I'm going to put 0 in place of x, and then I'm going to solve for y. So in this case, I just have to simplify. I can either put it in my calculator or I can work it out in my head, and I end up with 3. So my y-intercept is the 0.03, which you can see in the graph right here. Okay, positive and negative. So let's recall what those mean. Positive means above the x-axis. Negative is below the x-axis. So if I color blue the part of this that is above the x-axis, I'm going to end up with the whole thing. So my positive interval is forever to the left and forever to the right, negative infinity to positive infinity, or all real numbers. My negative interval, well, I don't have anything colored red. There's no part of it that's below the x-axis, so I'm just going to put none. All right, my next feature is going to be increasing and decreasing. Okay, so you remember, increasing means that it's going up, and I can see as I read from left to right that it's going up right here, and decreasing means going down. So I can see again as I go from left to right that it is decreasing right here. Be careful not to read from the vertex out. You want to read the graph from left to right. So increasing. Increasing is this part. And where does it start increasing? Well, that's going to be right here at the vertex. And you remember for intervals, we always use our x values. So that x value is going to be -1 because remember we shifted one place to the left. So my interval for increasing is going to be -1 to infinity and not including -1 because remember actually at -1 it is not increasing or decreasing. It's changing from one to the other. So my decreasing interval, that's here. My decreasing interval is going to be negative infinity to -1, and we said we're not going to include -1 on decreasing either. Okay, so how about in behavior? Let's fill in those blanks. So this one says as x approaches infinity. That means I'm going to the right And as my x values are getting bigger, what's happening to my y values? Well, that's going towards positive infinity. So I'll fill that into the blank there. All right, now let's look at this one. X approaches negative infinity. This is one of those rare times when you're going to read to the left. As x approaches negative infinity, as your x values are getting smaller, what are your y values doing? Well, they're still going toward positive infinity. So for both of those in behavior, I'm going to get positive infinity. Okay, let's do a different one. Let's do the cube root of x minus 4. Okay, so that negative 4 that's inside the function there, is that going to be horizontal or vertical? That's going to be a horizontal shift, and you remember when you're subtracting on a horizontal shift, that means you move to the right. So I'm going to take my cube root shape and I'm going to move it over here 4 places to the right. So I'm just going to sketch in that shape. All right, so there's my cube root graph, just a sketch. All right, let's look at domain and range. So domain, all the possible x values. So if I take my cube root graph and I just shift it over to the left, or the right, that doesn't change my domain. It doesn't change the fact that it's going on and on forever in both directions. It just means the quote unquote center of it has scooted over a little bit. All right, and the same is going to be true for range. For my y values, if it's already going from negative infinity to positive infinity, and I just scoot to the right a little bit, that's not going to change the fact that I'm still going from negative infinity to positive infinity. All right, x-intercepts. So to find the x-intercept, what did we say last time? You put 0 for y, and you solve for x. Okay, I'm going to have to get rid of that cube root there, so I'm going to cube both sides. So the cube and cube root will cancel out. And then what I'm going to have is 0 equals x minus 4. Adding 4 on both sides, I get x equals 4. Well, since the technology graphed this for me, that matches up really nicely. Also, I shifted 4 places to the right, but sometimes I'm going to choose not to trust my graph. I'm always going to trust my algebra. Sometimes, because I'm a person, my graph can be off a little bit, and the same thing for you. Trust your algebra more than you trust your graph. So your x-intercept is the point 4, 0. All right, let's find the y-intercept. So to find the y-intercept, I put 0 in place of x, and I solve for y. So 0 minus 4, negative 4. Well, negative 4 is not a perfect cube number, and I can't bring a factor tree in circle groups of 3. There's not enough, so I'm just going to bring out the negative cube root of 4, and that's what I have right there. I don't need to type that in my calculator. I can just leave it as a negative cube root of 4. So that's my y-intercept. Okay, positive. Remember, positive means above the x-axis, so that's going to be this part. And this one does have a negative part. Negative means below the x-axis. Still reading, though, from left to right. Okay, and where does it change? Where does it move from negative to positive? Well, that's going to happen right here at my x-intercept, which we said was at x equals 4. So when I write my intervals, I'm going to have 4 to infinity for my positive interval above the x-axis, not including the 4, because at 4, the y value is 0. And then for my negative interval, that's going to be negative infinity to 4, again not including the 4, because 0 itself is not positive or negative. Okay, how about increasing and decreasing? So increasing means going up. So as we move across the graph from left to right, I notice that this one is always increasing. So my increasing interval will be negative infinity to positive infinity. And if it's always increasing, what can I say about decreasing? Well, there will not be a decreasing interval. This one will be always increasing. Okay, let's look at end behavior. So as x goes to the right, as x approaches positive infinity, y is also approaching positive infinity. It's going up very slowly, but it is going up. as it moves to the right. And on the other one, as x approaches negative infinity, reading that one to the left, well, I can see that that one's going down. So negative infinity is what I'm going to get there. It's going down very slowly, but it is going down. Okay, let's do a trig one. So in this case, I'm going to take the graph of sine and I'm going to shift it pi over 2 radians to the right and also 1 unit up. Well, to move my 1 unit up, I'm going to think about that midline. The midline is normally on the axis, but I'm going to move that midline up 1 unit. And then my amplitude hasn't changed. My amplitude is still going to be 1, so I'm going to go up 1 and down 1 from that midline. Okay, so now let's worry about shifting pi over 2 to the right. So think about what sine normally looks like. Sine of 0 is 0. So normally I would have a point right here, but I'm going to shift that point pi over 2 units to the right and also up 1. Okay, normally on pi over 2, sine is equal to 1. But I'm going to take that point and I'm going to shift it pi over 2 units to the right and also up 1. So you can see my amplitude is 1. There is a distance of 1 between that point and the midline that I had before. Okay, so think about what the sine curve looks like. It first goes up, and then it goes down in the second quadrant, and then it continues to go down into the third quadrant towards negative 1. But if I take that negative 1 and I shift it up 1, then I'm here at 0. So the right-hand part would be this. I can't get the whole thing because it's past 2 pi. Okay, so now let's go to the left side. Normally, my sine curve from that first dot that would have been on 0, I'm going to go down and then back up again, down, and down. Okay, so let's go that way. So I'm going to go up, down, down. All right, so there is my sine curve shifted pi over 2 units to the right and also up 1. Okay, well, all that shifting, did it adjust my domain in any way? Not at all. My domain is still negative infinity to positive infinity. How about range? Well, when I moved the midline, I changed my range. My amplitude is still 1, but I'm going up and down 1 from the line y equals 1. So up from 1 would be 2, down from 1 would be 0. That does change my range. Okay, so how about period? I've changed this now to having a graph that came off of Desmos, so it's a little bit easier to see. So my period is 1 complete rotation. How long does 1 complete rotation take? So I can look from the bottom of one trough over to the bottom of another trough, or I can look from the top of a hill over to the top of the next hill. But either way, the distance between those dots, is still 2 pi. My period did not change. All right, the midline. You remember we dotted in that midline? The midline was up 1, but I can't just write 1 because the midline is a line. So I'm going to write y equals 1. All right, I didn't change the amplitude. Amplitude is still 1. Phase shift is just a trig way of saying how far did you move horizontally? How far did you move left and right? And in this case, I went pi over 2 to the right. Okay, let's try another one. Let's try cosecant. All right, so this one I'm going to shift down 2. So remember, cosecant is the reciprocal of sine. So what I'm going to do is I'm going to sketch in sine, and then I'm going to flip cosecant from there. So my midline for sine would have been at 0, but it moved down 2. I did not shift right or left. I did not change the amplitude. So I'm going to put my dots where sine would be as if this dotted line or the x-axis. So it's going to start at quote-unquote 0, and it's going to go up 1, and then it's going to go down, down again, and then back up. So you can see on the right-hand side here, oops, that needs to be dotted. On the right-hand side here, I have 1 complete sine curve. I'm just going to dot that in. Because remember, this isn't really the answer. This is just to help us get the answer. And then on the other side, I'm going to go the opposite direction. So I'm going to go down